So when we talk about OSPF, one of the things that we talked about this with EIGRP as well, is how do we make the protocol operate more efficiently, right? How do we make the protocol operate more efficiently? How did we do that in EIGRP? What were the two features that we had in EIGRP that allowed the protocol to operate more efficiently from the perspective of exchanging routes? Summarization was one, and stub routing features, right? EIGRP stub connected, stub summary, that kind of stuff. In this particular chapter or lesson, we're going to talk about that with respect to OSPF. OSPF, it's actually more critical in OSPF that we follow this procedure because OSPF, the link state database, is a lot more robust than an EIGRP topology table. The amount of information that we're exchanging in this protocol is much more significant. So we want to make sure that we're trying to maximize the efficiency of our link state database as part of the process. So route summarization is a very important concept, but unlike EIGRP, where I can summarize on a per interface basis, in OSPF, I'm only able to summarize on two different types of routers, an ABR and an ASBR. All right? In addition, in OSPF, we also have the capability of applying something called special area types. And there are 4 different special area types that exist in Cisco. Stub areas, totally stubby areas, not so stubby areas, and totally not so stubby areas. I think Brandon. So we are going to discuss that in this chapter. We're going to talk about the special area types. What is a stubby area? What is a totally stubby area? What is a not so stubby area? What is a totally not so stubby area? Again, the purpose of this function in OSPF is to reduce the size of our link state database to control what kind of routes can enter an area. All right? So in this lesson, we're going to talk about also the default routes. Clearly, we know that default routes are going to provide us the ability to essentially not have to advertise any routes. And it ensures that we have reachability, right? Default routes are very, very important for reducing the size of the routing table. Usually, we're going to use a default route in a stub network design where I only have one way in and one way out, and a default route is just more appropriate. The reality is when you're designing OSPF and you're creating your OSPF network, it is actually very important that you use the default route feature and the stub routing feature to scale the OSPF design. Okay? So we're going to talk about route summarization in OSPF. We're going to talk about the benefits of route summarization in this lesson. Also, how do we configure summarization on an area border router? What does that configuration look like on an autonomous system boundary router? We're going to take a look at injecting a default route and modifying the cost of a default route as it comes into the network. And then we're going to talk about how we can use default route and the stub routing feature to essentially allow reachability to networks that I don't have specific information for. We'll take a look at what an NSSA is, not so stubby area, and then we'll also take a look at the default information originate command as well. All right. So summarization, as you guys are aware, provides me the ability to reduce the size of my routing tables by taking a bunch of contiguous addresses and representing them as one large network. All right, the only place that we can actually perform summarization in our enterprise is on an ABR, going from one area to another, or on an ASBR, summarizing external routes into my OSPF autonomous system. We know that the summary routes come in on the ABR as a type 3 LSA, and the summary routes come in on an ASBR as a type 5 LSA. We talked about that in previous lessons. Okay? Why do they say a good addressing plan is required? We see this all the time when we're talking about summarization. Well, you want to make sure your summaries are as accurate as possible. You don't want to create a summary that includes 5 networks that you actually own, but then there's 100 other networks that are included that the router doesn't originate. So you can get suboptimal routing. You can have issues with loops getting created in the network because you got multiple routers that are advertising the same prefix and so on. So a good addressing plan is always very important in this particular case. We summarize to an area. We do not summarize, we do not summarize on a per interface basis. In OSPF, our summaries are actually configured in the routing process. It's not configured on a per interface basis like we see with EIGRP. In EIGRP, we summarize on a per interface basis, and we just simply apply the summary on the interface that we want the traffic to go out of or the summary to be advertised out of. In OSPF, it's completely different. We summarize in the routing process. Okay? So what are the benefits of route summarization? Obviously, to minimize the size of the routing table. But there's actually an additional benefit. We want to try to avoid doing shortest path first recalculations as much as possible, running Dijkstra's algorithm, trying to recalculate new paths, and so on. All right? Think about it from this perspective. I've got a bunch of routes in Area 1, maybe 1,000 routes in Area 1, and I've created a Type 1, see he keeps joining and leaving. I create a Type 3 LSA to summarize all of those Area 1 routes. Let's say that that Type 3 LSA is a single route that represents all 1,000 of those networks. What happens if an individual route goes down within the area? Does it change the summary? No. Which means that the rest of the autonomous system doesn't have to do a recalculation, doesn't have to change or run the shortest path first algorithm, and it doesn't have to worry about recalculating databases. Now, that means that these guys over here are still going to be routing to that network because they still think it's available, because up to the ABR it is available. It's part of the summary. Once I get to the ABR, the packet would get dropped because the ABR is part of the area, so it's learning about those prefixes as Type 1s. Make sense? Okay. What is the other possible scenario where a route that goes down in an area would affect the summary in the rest of the network? What is another scenario where a route that goes down within the area would affect the summary for the rest of the network? Remember how the metric is calculated for summary routes? We talked about this with the EIGRP. If I have 1,000 routes that are included in a summary, what is the seed metric for the summary route?
The highest.
The lowest metric of all the routes that are included in the summary. So it is possible that if that particular metric changes, like for example, the route that went down just happened to be the route that had the lowest metric, then yes, the summary would change. That would cause a recalculation in the rest of the network. Okay? I mean, you guys understand the benefit of summarization. We're trying to reduce the amount of LSAs that get flooded throughout the network. We're trying to save CPU cycles and CPU resources on the rest of the network. Remember, we say that LSAs only get flooded within an area. If you're not doing manual summarization, that's not true. Because if you have 1,000 Type 1 LSAs in Area 1, you're going to get 1,000 Type 3 LSAs into the backbone. By default, summarization is not enabled by default. So any change in Area 1 is going to result in a change in the Type 3s going out to Area 0. That's why it's really important that we consider this concept of summarization. So we're going to load up discovery number 12, and we're going to take a look at some of our summarization. If you take a look at the topology, unfortunately, they didn't in this particular exercise give us an example of an ASBR, but I will show you guys how it works on an ASBR. They may have that in the second discovery. I'll show you guys how it works on an ASBR as well. I'll just kind of I'll make router 3 an ASBR as well. And we'll do some summaries on the ASBR. So we've got a bunch of networks here that we want to summarize. We've got a bunch of networks here that we want to summarize. By the way, Kathy, what is the summary address that I'm going to use for those 4 networks? We talked about this before, right? We did some math. What's the first thing you ask yourself?
What is our common?
Well, no. How many networks? Block size. We're thinking in terms of block size. How many networks? 4. I look at the first network and I say, okay, I want a block of 4. Is 20 evenly divisible by 4? It is. So I know that I can summarize these 4 networks with one summary address. All right? What octet are we summarizing in? The third octet. Agreed? So a block of 4 in the third octet is 256 minus 4, which is 252. So the subnet mask is going to be 255.255.252.0, which is a slash what? Well, if it's 255.255.255.0, that's a slash 24. It's 255.255.252.0, which is 2 bits less. 24 minus 2 is 22. So my summary for this guy is going to be 192.168.20.0 slash 22. Okay? All right. What about this one? 32 to 39, 32, 33, 34, 35, 36, 37, 38, 39. That is a block of 8. Is 32 divisible by 8? Yes, it is. See, they gave us a nice, clean range of addresses to work with.
Never happens.
That never happens. That's right. That never happens. So we've got 32 is the starting address of our summary. We need a block of 8. 256 minus 8 is 248. So the mask is 255.255.248.0, which is a slash 21. Did you kind of follow that?
I can do it. I just have to draw it out.
Okay. All right. I'm trying to bring you along to think block size.
Yeah.
Trying to get you to think block size, but that's okay. That's all right. We'll get there. Maybe one day. All right. Anyway, it doesn't really matter. You know, in this case, we could even be a little bit more lenient on our summaries. We would try to be as specific as possible, of course. But the point here, though, is that we don't summarize on these routers because these are internal routers. You're not allowed to summarize on an internal router. If this was EIGRP, I would just simply put a summary right there, and I put a summary right there, IP summary address, EIGRP X, and then put in the summary. But we're only allowed to summarize on the area border router. So the first thing we want to do, is make sure we go into our topology. This is our topology that we built in GNS3 to kind of match what's in the lecture portion, as you guys are aware. And we're going to be summarizing these networks here. But in order to verify operation, let's go ahead and make sure that we see all those routes in R4. So let's go into R4 and do a show IP route OSPF. And I don't see anything. Of course not. Show IP OSPF interface. All right, doesn't look like OSPF is configured, so we'll have to drop that in. Okay, so we've gone through, we've actually fixed our routing issues. And if I look at router 4, show IP route pipe include OIA, I can see all of the type 3 LSAs coming from area 2 and area 1, which is the top router R2 and the bottom router R3. Obviously, we want to reduce the size of a routing table, so we want to be able to summarize these routes as part of the process. Okay? So we'll take a look at that process. I'll show you guys actually a couple of other things about how the metric is calculated. They probably don't do that in the courseware. They don't actually give you indication about how the metric is calculated and so on. So we'll take a look at that as part of the process as well. Everybody else get their labs kind of working?
Yeah.
Kathy's feverishly studying over there, I think.
My lab is working.
Okay, great.
And I am studying.
Yes, doing both at the same time. All right. So in step one, we'll go ahead and look at router one. Now, router one is not going to have any OIA routes. Why would router one not have any OIA routes? It's the ABR. It's a member of all of the different areas. So it's not going to have any OIA routes because it's the ABR. I don't know how else to say it. It's the member of all the other areas. So if I go into router one, and I look at the routing table on router one, show IP route, we can see that every route shows up as an OSPF route. This is a pretty important point though, by the way. Before you actually go in and you do your summarizations and you start to add your summaries, make sure that the router that you're summarizing on has all the routes that you want to include in the summary. Because if the routes don't exist on the router that's doing the summary, then the summaries are not going to exist. Plain and simple. So it's it's kind of appropriate to go make sure, okay, I've got my 20 route, I've got my 21, my 22, my 23, my 24. The 20 is kind of showing up here a little bit strangely, right? You'll see it's kind of listed almost separately from the rest, 20.1 versus 21.0, 22.0. That's because of the network type on the interface. So I can come into router 2 and go into interface loopback 0 and say IP OSPF network type point to point. Actually, it should be Ethernet in this case. Show IP OSPF interface. Yeah, it is broadcast. So changing it to point is not going to do any good. I think it's just showing up like that because of the way the interfaces are configured on the loopback. Show, actually, that's what I meant to do. Show IP OSPF interface. You look at the network type on the loopback, which has the 20.1 address, and it shows up as loopback. For some reason, OSPF doesn't do that. OSPF doesn't do that with the secondary addresses. It only does that with the primary address, where it advertises it as a /32. So I'm going to come in here and go into interface loopback 0, IP OSPF network type point to point. That way, when I go back, I'll do the same thing on router 3, by the way. Config T, interface loopback 0, IP OSPF, network type point to point. So when I go back to router 4 and I look at the routing table, now I see all my prefixes look symmetric. Right, we're just simulating these networks on the router anyway. Right, the loopback address is just there to simulate the networks, but we've got our 4 networks from router router 2, and we've got our 8 networks from router 3 listed down here. I was looking at the next hop there. That was interesting, but kind of makes sense. The next hop is, in fact, router 1, so it's going to be the 172.16.14.1 address that we have here. If I look at this from router 1's perspective, let's go back to router 1. I'll see and let's just do this, show IP route OSPF. We can see the O routes here. These are the routes coming from router 2, right here, and these are the routes coming from router 3. So our goal is to summarize these to reduce the overall impact on our area 0. Also, there's going to be some other things that we'll take a look at with the summary with regard to metrics and so on. All right, so let's see what they want us to do here. They're just investigating the routing table on the ABR in this case, which all those loopbacks. We look at router 4, we just did that. We see all the OIA routes Actually, it looks like they probably wanted us to have the network type in there for the loopback, because you can see from the output here that the 20.0 subnet is showing up as with a prefix of 24. So you may want to add that. It's not a big deal if you don't, but maybe you want to add the IP OSPF network type point-to-point on your loopback interfaces just to make it consistent. All right, so these are all the routes coming in as type 3s. OIA is a type 3 route. And we can actually go in and do a show IP OSPF database on router number 4. Show IP OSPF database. And sure enough, for the summary netlink states, which are the type 3s, we can see all of the summary routes coming in as well. So we're trying to shrink the size of this database. We're trying to make the database more efficient. I want the 20, the 21, the 22, and the 23 to be summarized, and the 32 through the 39 to be summarized. All right. These are all coming in as type 3s from router number 1, which is my ABR. All right. Summarization. We already calculated the summaries. Now we have to apply the summaries. We're going to go into router 1 because that is our ABR, and we're going to apply those summaries using the area range command. The area range command. Very important point here, because in EIGRP we were summarizing out of an interface. We were configuring a summary on an interface to indicate that the summary was going to go out of that interface. In the case of OSPF, this number here, the number that you see here, the 1 and the 2, that is the area that we're summarizing from, not to. That is the area that we're summarizing from. So we're automatically going to summarize on router 1 into the other areas that are not included. So if router 1 was part of 5 or 6 different areas, and I was summarizing from area 1, then it would automatically summarize into those other 5 or 6 areas. Does it make sense? So we're not specifying where we're summarizing to, we're specifying where we're summarizing from. And we use the area range command to do that. So let's go into router 1, and let's go ahead and set up our area range command. That's under the process, config T. Router OSPF 1. Let me make sure I'm using process ID 1. To show IP protocols. Pipe include process. Oops. OSPF. What the heck is it? There we go. OSPF 1. All right. So routing protocols OSPF 1. So router OSPF 1 and area 1 range. And that was going to be, what was the networks? 192.168.20.0. 192.168.20.0 with a mask of 255.255.252.0. That is a block of 4 starting at 20. Because 20 is evenly divisible by 4, this is allowed. It has to do with the way the binary math is calculated. But a block of 4 starting at 20, okay, which is going to include 20, 21, 22, and 23. All right, and then area 2 range. And in this case, I want to summarize these networks here, 32 through 39, which is a block of 8 starting at 32. 192.168.32.0, 255.255.248.0. That is a block of 8 starting at 32. That's it. It's that simple. Now if I go into router number 4, I look at my database again, you will see that my summary netlink states didn't change. Why not? This one changed. Why did the other one not change? Still seeing 33, 34, 35. Interesting. Yeah, it could be time. Let's take a look. Ah, there we go. Yeah. We were still converging. OSPF is so slow. I'm kidding. It's pretty fast. All right. Pretty fast. All right, 20.0 to 32.0. And if we drill down, show IP OSPF database summary, we can actually see the prefixes that are being advertised as part of those networks. So there's my /22 for the 20 subnet, and there's my /21 for the 32 subnet. Okay? Also notice what the seed metric is. The cost for those routes is 11. Now remember what I said about the cost when it comes to summaries. The cost of the summary is the lowest metric for the routes that are included as part of the summary. Unfortunately, in our particular case, we're a little bit limited in how we can manipulate the cost. We could do a route map and apply a cost or put some sort of manipulation on the route itself. I'm going to do something a little bit different here. It's not in the book, but what the heck, we'll play around a little bit. So show IP, let's just do a show run, interface loopback 0. So I've got these different secondaries here. I am going to go ahead and change, I'll take the 23 off of here, and I'll just create a separate loopback with the 23, and I'll enable OSPF on that. So config T, interface loopback 0. We'll take off the 23 network from here. Interface loopback 1. We'll go ahead and add the 23 network on that guy. And I'll add that to OSPF as well. We still should have that network, 23. It's right here. And it should still be advertised to router 1. Do show IP route. Pipe include .23. So we're still getting the 23 route as an OSPF route, which means that our summary is still effective. Now the reason I did that, I separated those, is because I want to be able to demonstrate the concept of this seed metric. If I go to router 4, for example, okay, show IP route OSPF, we can see that the seed metric, or the metric actually for this route, is 21. All right, well, on the ABR, the metric was 11, plus we have the cost of the link to get from the ABR to router 4. That's this path right here. That's going to give me a cost of 10, so that's 21 total. Okay, all right. So the reason I separated that loopback is because I want to demonstrate or prove to you guys the concept of lowest metric becomes the seed metric for the summary. Now, keep in mind, these 4 routes are being advertised over to router 1 with a metric. We've got a cost of 1 for the loopbacks themselves plus a cost of 10, so they're coming over with a cost of 11. That's going to be a bit of a challenge because I just realized I'm not really going to be able to change the cost of that loopback to anything less than 1. So I'm going to have to change the reference bandwidth on router 2 to be able to affect the metric, the seed metric. So router OSPF 1, auto cost reference bandwidth, I'll do 10,000. All right. So now if I do a show IP OSPF interface, I can see that the loopbacks have, well, they still have a cost of 1. I need to change my reference bandwidth to a higher value. We'll just make it that big. All right. Still a cost of 1. Why is it not changing? See the bandwidth. Actually, you know what? No, it's a loopback. It should still, the cost should still be calculated. Let's see, if I've changed the metric to 10 to the power of 10 divided by 8, So it's rounding down to 1 if I have a metric of 10, but I changed it to the reference bandwidth to higher than that. Yeah, it doesn't let me go that high. Show IP OSPF interface. Interesting. It's definitely changing the cost of Ethernet. I wonder, you might be right. Maybe maybe the cost calculation for loopback interfaces doesn't change. All right. Well, that's going to be a bit of a challenge. So what I can do, I was going to try and play around with the auto cost reference bandwidth, but that's being a pain. So what I can do is instead come into interface loopback 0 and go ahead and give that a cost, IP OSPF cost, and we'll just make that 20. Sorry, cost 20. And interface loopback 1. I'm going to give it the same cost for now. Okay. So when I come back over to router 4, the original metric for that path was 21. Now if I do a show IP route, we can see that it's 40. All right. So I'm adding the cost of the loopback. Let's go to our diagram here. I'm adding the cost of the loopback, which is 20, plus the cost of this path, which is 10, plus the cost of this path, which is 10. But remember, on router 4, I'm receiving that summary route. Even though it looks like a normal OSPF route, or a normal type 3 OSPF route, I'm receiving that as a summary /20/22. So the point that I was trying to make is that the seed metric for the summary is whatever the lowest cost is of all the routes that are included in the summary. If I go over to router number 1 and I look at show IP route pipe include 192.168.2, these are the 4 routes that are coming in from the loopback. They all have a cost of 30, which makes sense. So these are the routes I'm summarizing. That becomes the seed metric for my summary, and then I add the link between the router 1 and router 4. That gives me a total path cost of 40. But if I go ahead and change on router 2, the cost of loopback 1, do IP OSPF cost, I'll just make this one 19. Just make it 1 less. Go back to router 1, same output. You can see, there we go, that this route 23 has a cost of 29. These 3 routes have a cost of 30. Now if I go to router 4, you will see that this route, which previously had a cost of 40, now should have a cost of 39, because it's assuming that the seed metric for the summary is the lowest metric of all the routes that are included within the summary. Does that make sense? It's just the way it's done. You can't change that behavior. I guess it's kind of like the cup is half full scenario, right? Just to be clear about what I did here, these are where the routes are originating. Show run. These are where the routes are originating from. The loopback interface is on router 2. So those are the 3 networks, 20, 21, and 22. I split out the 23 so I can manipulate the 23 separately. And I put the cost of 20 on that loopback, and I put the cost of 19 on that loopback, just to show you that the summary route became 19. Okay? What else should I see on R1? We talked about this with EIGRP as well. What else should I see on R1? Whenever I do a summary on any router, what should I see? A null zero route. Sure enough, you see that right here. Remember that null zero route is used for loop avoidance. In this particular case, we're not really concerned, because all of our summary is exact. Our summary only includes the 20, the 21, and the 22, and the 23 subnet. But that null zero route, in the event that I might be summarizing more than what I'm supposed to be summarizing, the null zero route allows us to drop those packets that get routed to that router in the event. Well, actually, we can demonstrate this. Now that I split out 23, I can demonstrate this concept. So I can come into router 2 and I can say, okay, I'm going to come in here and I'm going to demonstrate a couple of things with this. See, this is why I did this. This is the whole reason, right? Check out on router 4, show IP OSPF, and if I look at area 0, the SPF algorithm has been calculated 6 times. That means that we've had 6 topology changes, and that's affected us. What's going to happen when I shut down loopback 1 on router number 1? Excuse me, router number 2. What's going to happen when I shut down loopback 1 on router number 2? Specific to the summary. You sure it's nothing? What's going to happen when I shut down loopback 1 on router number 2? The metric for the summary is going to change, isn't it?
I thought it went off the lowest.
It is the lowest. Loopback 1 is a 19. Loopback 0, which has all the other networks, is a 20. Right?
That's how I was originally looking at it.
Yeah.
It goes off the quickest route.
So even if it calculates the lowest for the summary and something else comes online that's lower,
It would change it. It would change it. The point that I'm going to try to make here is, does that result in a SPF calculation?
That's what I
I
was
would think
answering.
so.
Right.
I don't think it would.
You don't think it would if the metric changes but the route doesn't change. You don't think it would result in a change. Okay, well, let's see. This is kind of why we do this. We get to play around and see. So just to confirm, show IP route 192.168.20.0. The metric for this guy is 39. And it is a summary, /22. So I'm going to go into router number 2. Config T, interface, loopback 1. And I'm going to shut down that interface. Now, if I go to router 4, a couple of refreshes here. There we go. The metric changed to 40. Show IP OSPF. Did that result in a SPF algorithm execution? And the answer is no. So it wasn't, the route didn't change, just the way the route looked or the cost of the route changed, but it didn't force us to run a recalculation in the area. Okay? I was actually going down this path because I was describing the null zero concept. If I go into router 1 and I do a debug IP ICMP, and I come over to router 4 and I ping the 192.168.23.1 address. Remember, that's the address that was on loopback 1. Well, that network doesn't exist anymore. This router thinks it can get there because it is part of this route right here. So if I hit return, I get an unreachable. Sure enough, on router 1, which is the ABR, it's responding with the destination is unreachable. What's happening with the packet? It's going from router 4 to router 1. Router 1 is advertising that that network exists, but because router 1, show IP route pipe include 192.168.2, because router 1 doesn't include a 23 subnet with a /24, the 23 route gets matched to the null zero interface and the packet gets dropped. That's your loop avoidance mechanism in action. Come back to router 2, do a no shut. The metric of the route is going to change on router 4. Should go back to 39. There we go. Goes back to 39. Obviously, a ping to that network will work because now in router 1, we have a specific route. All of this stuff ties together. right? We have a more specific route. Well, the ping actually matches this route and this route because this is a longer prefix. It's going to use that route instead of the /22. This is all stuff we talked about when we talked about EIGRP, right? This concept of the null zero route and everything else. Okay? All right. So they went through a bunch of demonstrations here, same concept. Look at the route. We see the route, a /21 in this case, and we see the other route, a /22, and then they're looking at the OIA routes and so on. We did all this stuff. We looked at the database. We looked at the null zero route, which we just actually looked at. The null zero route is directly related to the summary. We talked about what the purpose of a null zero route was as a loop avoidance mechanism in our topology. All right. So OSPF has two options for doing route summarization actually. We've got two options. We can summarize internal routes on the ABR, or we can summarize external routes on an ASBR. Now in our particular case, we don't actually have an ASBR, but I can create one. We'll do that in a little bit. So we left off before we took our break, a summarization on an ABR. We just talked about that. Two different methods of summarization. We can summarize on the ABR using the area range command, but we can also summarize on our external routers on the ASBR. We can take routes from an external system and then send them into OSPF. I don't know if they actually have an exercise in this lesson that describes that, but if we don't see it, I will go through that with you guys and we'll discuss that, that part of it, all right? Without the summarization, we know we're going to be sending in too many routes into our autonomous system. So when we're going to summarize on an ASBR, remember, we're not summarizing from an area. When we're doing our summaries on an ABR, the area ID that we're specifying is the area from which we're summarizing, okay? It's page 276, 277 actually. Okay, when we're summarizing on an ASBR, we're taking routes from an external domain and we're sending them into OSPF, so we use the summary address command. We don't use the area range command. So in this particular case, I'd be summarizing networks 172.16, 32, 33, 34, 35. Well, it's basically a block of what? 32 addresses. This is a 224, 256 minus 224 is 32. So this is going to take us all the way from 32 to 63. In our particular topology here, we don't have any external routes to summarize, so we can't identify the external routes that are going to go into the network. But I could do that, I suppose. We could go into router 3, for example, and I could create some loopbacks real quick. Let's do a show IP interface brief, include up. Up. So we've got loopback 0. So if I go into interface loopback 1, config T, interface loopback 1, IP address 10.10.10.1, 255.255.255.0, and interface loopback 2, IP address 10.10.10.11.1, 255.255.255.0. So if we do a show run include connected, let me do just a C in this case. Oops, sorry. Do a show IP route, include connected. So we have our two loopbacks here, loopback 1 and 2. Now if I wanted to summarize those, these are not part of the OSPF process. So in order to make R3 an ASBR, I need to go into router OSPF 1, and I'm going to just do a redistribute static to take, redistribute connected. We'll see if that works. Subnet, sorry. We'll see if that works. Let me do a quick show IP OSPF database. and see if those are showing up now. 10 links from router 3. Let's see what that looks like if the networks are included here. We've got 192, 168. There's 35, 34, 36, 39. So they're not included yet because when we do a redistribute connected, we're only redistributing connected routes that are part of OSPF. Let me do this a different way. How can I do this? All right, so if I do a show run section router, we can see that we've gone ahead and set up a couple of loopbacks in the 10 network under EIGRP 100, and we're redistributing that into OSPF. So these are coming in to OSPF on router 3 as external networks. And in fact, if we go over to router 4, we can actually see those routes. Show IP route OSPF, pipe include EX, OE2. And those are the two routes that are coming in from router 3. They're coming in as an OE2, which is an external type 2. We'll talk about what that means a little bit later on. It has to do with how the metric is calculated as the routes move across the network. But I want to summarize these two networks to reduce the size of the routing table into one common subnet. We would do this on the ASBR. In this case, router 3 is the ASBR. And if you look at the syntax, it's done under the router configuration mode using the summary address command. This is the only time I would use this. I would use area range if it's an ABR. I use summary address if it's an ASBR. All right, so config T, router OSPF 1. And we're going to do a summary address of, well, in this case, I guess it's just going to be the two 10 networks, right? So 10.10.10 and 10.10.11. So what would the summary be for those two networks? 10.10.10.0, 10 and 11. 10 and 11 is a block size of 2. Agreed? 10 and 11 is a block size of 2. So it would be a 255.255.254.0. That would be a block of 2 starting at 10. 256 minus 254 is 2. Go back to router 4. We see the route is now being advertised. Let me just do a quick show IP route OSPF. You can see that the route is being advertised with a /23 mask. Okay? Still looks like a regular or OSPF route, administrative distance of 110. If I go to the ASBR that's actually generating the summary, do a show IP route, pipe include null, you can see that the router created a local OSPF route to the null 0 interface. Again, loop avoidance mechanism, but it works just like it does on an ABR with an ASBR. All right. Now I'm guessing in this particular case that that they might have a scenario a little bit later on where we talk about doing this a little bit later on. But I wanted to demonstrate that concept. The routes coming in from, actually let me pull up the diagram here. The routes coming in from router 3 as a type 5 route, it's being passed through the entire autonomous system as a type 5 route. But prior to being sent into the autonomous system, it's being summarized on router 3. So summary address, if I'm going to create summaries on an ASBR and we're going to use the area range command if I'm summarizing on an ABR. Another concept that's important to understand is the concept of how we direct traffic to the internet. Typically, we're directing traffic to the internet using some sort of default route, right? Maybe we have some internet connection on router 4 in our backbone area, and we want to make sure that we're injecting a default route into our autonomous system. If I come over to my router here, and I do a show IP route, include gateway, you can see that gateway, the gateway of last resort is not set, meaning that I don't have a default route in this particular router. In fact, I don't have a default route anywhere in my entire enterprise. One of the options that we have to inject the default route is to use the default information originate command. Interestingly enough, when I do add the default information originate command, it will start injecting a default route as a type 5 LSA for the rest of the domain. So let's say, for example, on my ASBR router 3, I did a default information originate, which is done under the routing process. Default information originate, default dash information originate. Okay, so I've done this on router 3, assuming in this case that router 3 is connected to the internet. I'm going to inject the default route back into OSPF. If I go back to router 1, I will see that I still don't have a gateway of last resort. It's not set. Here's the reason why. With a default information originate command, router 3 is only allowed to advertise a default route into OSPF if it has its own default route configured, statically or through some other dynamic process. Because I don't have a default route configured on this router, it's not going to inject the route into OSPF. So you could add the option always. You add the option always that instructs the router to always inject the default route, even if it doesn't have its own default route. So now if I go back to router 1, I can see that the gateway of last resort is set to go through router 3. And you'll see that that route is being injected into OSPF as an OE2 route. We don't know what the 2 represents yet, but we know that OE represents an external route, which is a type 5 route. Okay? We don't necessarily want to use the always option, but if you only have one connection to the internet and you don't have any other option of reaching the internet other than through, say, this ASBR, a default information originate always is perfectly fine. What's the downside to using the always option? We might not know what to do with that traffic when it gets to me, but I guarantee you that all the unknown traffic is going to come to me. So everybody that's routing to destinations that are unknown are going to send their traffic to the ASBR, even if the ASBR can't reach that destination. That can be a bit of a downside as well. All right, so what we're going to do is we're going to load up our next discovery, which is discovery number 13. And in discovery number 13, we're going to talk about special area types. Very, very important concept, special area types. Stub areas, totally stubby areas, not so stubby areas, and totally not so stubby areas. So we'll go ahead and load up our config, and we'll start to look at our discovery 13.